Hello students, how are you all? Today I'm going to solve numericals based on meter bridge, potentiometer and several other previous recently asked Neet questions. Okay, and hope you are following the remaining videos also. This is the last part of current electricity. Okay, without any delay, let's get started. So till now I just completed one not two questions. Now today I'm going to start with question number 103. Let's get started. So look at question number 103. A resistance wire is connected in the left gap of the meter bridge. Balance is a 10 ohm resistance in the right gap at a point which divides the bridge wire in the ratio 3:2. If the length of the resistance wire is 1.5 meter, then the length of 1 ohm of the resistance wire is, okay, let's try. First of all, let me draw the circuit. This is the general circuit of meter bridge. If you observe this, they already gave known resistance and unknown resistance. The ratio of these two lengths, that is L1 by L2. So under balanced condition, galvanometer shows null deflection. That means product of the opposite resistance is equal, that is X into L2 is equal to L1 into 10 and X by 10 is equal to L1 by L2, where L1 by L2 ratio is 3 by 2. Then X is equal to 3 by 2 into 10, which is equal to 15 ohms. This is the resistance. Okay, but this is not the actual thing that they are asking. So let's see what they are asking. The thing that they are asking is, so we are getting 15 ohms per 1.5 meter length wire. Then for 1 ohm, then what's the length of the wire? That's what they're asking. So let me name this is as L. This can be written as L is equal to 1 divided by 15 into 1.5. So 1.5 can be written as 15 into 10 power minus 1. So 15 will get cancelled. You are going to get 10 power minus 1 meter. Okay, which option matches? Option B is the correct answer. Let's move on to the next question. The meter bridge shown is in balanced position with P by Q is equal to L1 by L2. If you are now interchanging the position of galvanometer and cell, will the bridge work? If yes, what will be the balanced condition? Okay. Even if you interchange the position of galvanometer and cell, there won't be any kind of change in the circuit, including a balance condition also. Yes, this bridge will work. At the same time, balancing condition also remains the same. So for question number 104, which option? Yes, it will work. At the same time, balancing condition is also same. Okay, understood? Okay, let's move on to the next one. The resistances in the two arms of the meter bridge are 5 ohm and R ohm respectively. When the resistance R is shunted with an equal resistance, the new balance point is at 1.6 times of L1. The resistance R is, okay, let me solve this. If the circuit is like this is 5 ohm and one more resistor R ohm. Then observe the balancing condition, galvanometer. So one is L1, another one is 100 minus L1. Okay. If resistor R is shunted with another resistance which is of equal value, then this balancing condition is going to be changed. Balancing condition is going to occur at 1.6 times of L1. remaining length is going to be 100 minus 1.6 times of L1, and this is 5 ohm. This is R and R. That's what they said. This is case 2. Let me write down balancing condition for the case 1. In the first case 1, it's going to be 5 into 100 minus L1, which is equal to L1 into R. This is 500 minus 5L1 equal to L1R. And 500 is equal to R plus 5 into L1. Let's say this is equation 1. In this equation 2, 5 into 100 minus 1.6 times of L1, which is equal to R connected in parallel with R, it's going to be R by 2. R by 2 into 1.6 times of L1, which is 500 minus 8L1 equal to 0.8 into R L1. From this 500 is equal to L1 common 0.8 R plus R plus 8 into L1, and this is equation 2. Let's solve these two equations. Divide both of them. Equation 1 divided by equation 2. Left side I'm going to left with 1 itself. Then this is R plus 5 into L1 by 0.8 R plus 8 into L1. L1 will get cancelled. 0.8 R plus 8 is equal to R plus 5. Send this to right side. It's going to be 0.2 R is equal to 3. Then R is equal to 15 ohm. Which option? Option B is the correct answer. Understood? Okay. So let's move on to the next question. Hope you guys are following. Okay. Next question number 106. In a meter bridge, the balancing length from left end is found to be 20 centimeter. The value of unknown resistance is, okay, super. Observe the circuit. So from the given data, I just represented this circuit. They already given standard resistance of 1 ohm in the right gap. Okay, left side gap is unknown resistance, and under balanced condition, product of opposite resistance is same. That is x into 80 is equal to 20. Then x is equal to 1 by 4, which is equal to 0.25 ohms. Option D is the correct answer for question number 106. Understood? Next, let's move on to the next question. Question number 107. From now, we are going to solve numericals based on potentiometer. A potentiometer is an accurate and versatile device to make electrical measurements of EMF because the method involves the condition of no current flows through the galvanometer. This is the key point in solving numericals. Okay. So for question number 107, option B is the correct answer. Let's move on to the next one. A potentiometer wire is 100 centimeter long and a constant potential difference is maintained across it. Two cells are connected in series first to support each other. Okay. So this question is based on comparison of EMF of cells. We have three purposes of the potentiometer. So let me give that. Let me write down the data. So what is the use of this potentiometer? Observe this. These are the main advantages of potentiometer. One is to compare. So one is to find out EMF of a cell. That is E is equal to K times of L, where L is balancing point from left hand. K is potential gradient. And L is balancing length. Generally from left hand we are going to consider balancing length. And to compare EMF of two cells, that is E1 by E2 is equal to L1 by L2. This is the way to compare. And the last purpose to find out internal resistance, that is small r is equal to capital R into L1 by L2 minus 1. These are the three major purposes of the potentiometer. Okay, so just observe the given data. So total length of the potentiometer is 100 centimeter long and a constant potential difference maintained it across it. Two cells are connected in series, first in supporting each other. Okay, super. Question number 108. Just observe the diagram. So two cells are connected first in series aiding, next they are connected in series opposing, and they have given their balancing lengths also. We know the procedure, it's based on second point. To compare EMF of two cells, in the sense it's going to be E1 by E2 is equal to balancing lengths ratio, that is L1 by L2. Here what is E net? E net is equal to E1 plus E2 because the cells are in series aiding, and here E net is equal to, it's going to be E1 minus E2 because cells are in series opposing. Balancing length 50 and 10 centimeters. Then it's going to be E1 plus E2 by 2. E1 minus E2, which is equal to 50 divided by 10. Centimeter will get cancelled. It's going to be, so E1 plus E2 is equal to 5 times of E1 minus 5 times of E2. Okay, send this E1 right side, this E2 left side. It's going to be 6 times of E2 is equal to 4 times of E1. Question they're asking, the ratio of EMFs is, that means E1 by E2 I needed. So E1 divided by E2 is equal to 6 by 4, which is equal to 3 by 2. Option B is the correct answer for question number 108. Hope you understand. So this question is based on comparison of EMF of two cells. Okay, let's move on to the next question. Question number 109. So whenever you are about to solve the numericals based on potentiometer, you should be in a position to draw the diagram. You have to remember it. Okay, then only it is easy. Let's move on to the next question. Before that, I'll draw the circuit based on the given data. A potentiometer wire of length L and a resistor small r are connected in series with a battery of EMF E0. Look at this. So this is battery of EMF E0, internal resistance small r, and this is the potentiometer wire which is of length L. Okay. Resistance is R1. Okay, EMF and internal resistance is R1. Okay. An unknown EMF E balances at length L of the potentiometer wire. Okay. So they are connecting an unknown EMF E with the help of a galvanometer, and it is being balanced at length small l from the left end here. The EMF of E will be given by, so they are asking EMF of this cell. So we already know the formula, that is EMF of the cell is equal to K times of L. This L is balancing length, right? Okay, so what about this E? Sorry, what about this K? K is potential gradient, right? Potential gradient. Meaning of potential gradient is potential across the potentiometer wire divided by its length. It is K is equal to V by L. This is voltage or potential across. Voltage across potentiometer wire. Potentiometer wire. And this is total length of the potentiometer wire. Total length of the potentiometer wire. So this is what the given data. First of all, let me calculate what is going to be the potential gradient. Now, whenever bridge is balanced, they have already given balance condition, right? So current flowing through this galvanometer is 0. Then current will circulate here itself. First of all, let me find out current in the circuit. So I is equal to E by R, E naught by R. So they have given internal resistance of this potentiometer wire also, that is smaller. Then total resistance is R plus R dash or R1, which is flowing through the circuit, and it always flows from positive to negative like this. As this complete wire is of resistance smaller, a voltage will drop across this resistor. The formula for voltage across, let's say this is point A and this is point B, which is voltage across potentiometer wire. Then voltage across potentiometer wire is equal to I into smaller, where I is E naught by R plus R1 into smaller. This is complete voltage across the potentiometer wire. Now what should I have to find out? Potential gradient. So E is equal to K is VAB divided by L. Capital L is the length of the potentiometer wire into balancing length. So VAB is E naught into smaller divided by R plus R1 into L by capital L. This is EMF of the unknown cell. So which option matches? Option D is the correct answer for this. Hope you understand the procedure. Understood? Let's solve the next question. A potentiometer wire has a length 4 meter and resistance 8 ohm. The resistance that must be connected in series with the wire and an accumulator of EMF 2 volts so as to get potential gradient 1 millivolt per centimeter on the wire is. Based on the given data, this is the circuit that we can draw. The thing that they are asking is to get 1 millivolt per centimeter on the wire. What should be the value of this Kepler? That's what they are asking. Okay, let's try. So from the given data, so we'll use this 1 millivolt per centimeter itself. What is the total length of this wire? Total length of the wire is 4 meter, nothing but 400 centimeter, right? So length is 400 centimeter. So what is the potential gradient? Potential gradient here it is 1 millivolt per centimeter. 1 millivolt per centimeter. Then what will be the value of potential across 4 meter wire? Then it's going to be K times of L, which is equal to 1 into 10 power minus 3 divided by centimeter into 400 centimeter. The centimeter will get cancelled. So 10 power minus 3 into 10 power plus 2 is 10 power minus 1. It's going to be 0.4 volts is across potentiometer wire. This is the potential across potentiometer wire. Okay. I know. Do I know the value of resistance of that potentiometer? Yes, I know. What's the value of potentiometer wire resistance? It's going to be 8 ohm, right? Then how to find out current flowing through it? I is equal to V by R, where V is 0.4, R is 8, which is equal to 0.05. Sorry. 0.5 amperes. This is the current flowing through the circuit. Now if you observe one point here, so what is the total voltage which is given to the circuit? It is 2 volt. How much voltage is appearing across this potentiometer wire? 0.4 volt. What is the remaining voltage which is present across this potentiometer, internal resistance, which is equal to 1.6 volts, right? That's the remaining voltage. Total voltage is 2 volt. 4 volts is appearing across potentiometer wire. Remaining potential will appear across 1 point across the internal resistance, that is 1.6 volt. So I know what is the voltage across it, and I know what is the current flowing through this. Current flowing through it is 0.05 ampere. Then how to find out resistance? R is equal to V by I, where V is 1.6 divided by I is 0.05, which can be replaced as 160 by 5. So it can be replaced as 5 3s are 15 and 5 2s are. So this is the value of resistance, which is 32 ohms. Got it? Let's solve question number 111. A potentiometer circuit has been set up for finding the internal resistance of a given cell. What's the formula for internal resistance of a given cell? This is the last case of potentiometer wire uses. That is, R is equal to capital R into L1 divided by L2 minus 1. This is the formula, right? We can use this formula directly to find out the answer here. The main battery used across the potentiometer wire has a EMF of 2 volts and a negligible internal resistance. The potentiometer wire itself is of 4 meter long. When the resistance capital R connected across the given cell has a values of infinity and 9.5. See, the meaning of case 1 capital R is infinity in the sense switch K is opened. That means we are not taking R into consideration. In this case is directly proportional to L1. Okay, hope you are able to understand. Now second case, they are saying R is equal to some 9.5 ohm. In this case, switch is closed. Switch is closed. In this here, K is a switch is closed. Then E minus I times of R1 is proportional to L1. Otherwise, we can replace it like this. Voltage across this load resistor, that is E into R divided by R plus capital R. So this is the relation. From this relation itself, we are going to get this answer. Okay, so in this case, they are given balancing points L1 and L2 here. One is 3 centimeter, another one is 2.85 centimeter respectively. The value of internal resistance. Small r is equal to, what's the value of capital R? It's 9.5, where L1 is 3, L2 is 2.85 minus 1. So which is equal to 9.5. 3 minus 2.85 divided by 2.85. If you solve this, you are going to get answer approximately equal to 0.5 ohm. Got it? It's a direct answer. So let's move on to the next one. Question number 112. A potentiometer circuit is set up as shown. The potentiometer, a potential gradient across the potentiometer wire is K volt per centimeter. The ammeter present in the circuit reads 1 ampere. When the two-way key is switched off, the balance points when the key between the terminals 1 and 2 and 1 and 3 is plugged in are found to be at lengths L1 centimeter and L2 centimeter respectively. The magnitudes of capital R and X in ohms are then equal respectively to, okay, super, they are asking R and X. Okay, so when they are connecting 2 and 1, okay, then voltage across this resistor is the same as voltage across these 2 points. That is, let's say current flowing through the circuit is 1 ampere, right? So voltage across the resistor, that is I into R, is equal to K times of L1. Balancing point is L1. Let's say this is case 1. Second case, they are connecting point 3 and 1. That means this one. That means voltage across these two is going to be voltage across these two. So that is I into R is equal to, it's not I into R, it's going to be I into R plus X is equal to K times of L2. This is equation 2. So if you solve these two equations, you are going to get the answer here. I will get cancelled. R by R plus X is equal to, K will get cancelled, L1 by L2. Then from this, R L2 is equal to R L1 plus X L1. So from this, we have to find out R and X separately, right? Send this to left side. R into L2 minus L1 is equal to X times of L1. Then from this, we know one thing, that can we replace R in terms of K and L1? Yes, we can. It's going to be K times of L1, L2 minus L1, which is equal to X times of L1. L1 will get cancelled. Then X is equal to K into L2 minus L1, right? Okay, so that is X. Then R is equal to K times of L1. So which option matches here? Option B is the correct answer for question number 112. Understood? Okay. Next, question number 113. A cell can be balanced against 110 centimeter and 100 centimeter of a potentiometer wire respectively, with and without being short circuited through a resistance of 10 ohm, the internal resistance. Okay, they are asking direct question. Small r is equal to capital R into L1 by L2 minus 1. Small r is equal to capital R. What's the value of capital R? Capital R is 10 ohms. Okay, into L1 is 110, L2 is 100 minus 1, which is 10 into 110 minus 100 divided by 100, which is equal to 110 minus 100 is 10, 10 into 10, 100, 100 by 100, 1. So final answer is 1 ohm. Which option? Option C is the correct answer for question number 113. It's a direct answer. Let's solve question number 114. If specific resistance of potentiometer wire is 10 power minus 7 ohm meter, it's 114. Again, specific resistance which is equal to 10 power minus 7 ohm, and current flows through it I is equal to 0.1 ampere. Cross-sectional area is given. Area is equal to 10 power minus 6 meter square. Then potential gradient will be. Formula for potential gradient is V by L, where L is length of the potentiometer wire. V is I into R divided by L, where R is rho L by A, where L will get cancelled out. So from the given data we can answer potential gradient as I into rho divided by A, where I is 0.1 ampere, rho is 10 power minus 7 divided by area is 10 power minus 6. So if it goes to numerator, it is going to be 10 power plus 6, 10 power minus 1 will be there. Already 0.1 is there. So final answer is going to be 10 power minus 2 volt per meter is the answer. Option A is the correct answer for this. Next, the potentiometer is best measuring voltage as it measures potential difference like a open circuit, correct? Because whenever bridge is balanced, galvanometer current is 0, so it's like a open circuit only. Volt EMF of the cell is the same as potential difference at which potential meter is being balanced. So that is going to be same as EMF of the cell. It's like we are measuring potential difference in an open circuit only. Okay, next to question number 116. A potentiometer consists of a wire of length 4 meter and resistance 10 ohm is connected to a cell of EMF 2 volts. The potential difference per unit length of the wire is. That means they are asking potential gradient. Okay. This is the circuit diagram for the question 116. So if you observe here, what is the potential across potentiometer wire? It is 2 volts. Then potential gradient is V by L, where V is voltage across that potentiometer, which is potentiometer wire, which is 2 volt divided by 4 meter. So it's going to be 1 by 2. 1 by 2 is 0.5 volt per meter. Option C is the correct answer for this. This is question number 116, right? Okay. Which option? Option C is correct. Got it? Let's solve question number 117, which is 2021 Neet question. They're asking us to compare. They're given some codes, column 1, column 2. We just have to compare them. So drift velocity formula is just direct formula. Drift velocity formula is QE by M into tau. Electrical resistivity formula is this one, E by J. So how can we write it? J is equal to sigma E, right? This one can be replaced as E by rho. Then resistivity is equal to E by J. So this is how we can write down resistivity formula. Current density can be replaced here as this one, N E V D. Actual current formula is N E A V D, right? Bring this to denominator. I by A is equal to N E V D. I by A is nothing but current density. So A to 3, okay. Next B to 4, as it is. So these two are matching. These are the matching only for the first option alone. So this is the correct answer. Remaining also matches for this. Current density, last option 4 is 2. D is 2. Yes, correct. So remaining is 1. Understood? Okay, super. Next question. Next question is 2021 question again. I think 3 questions came in 2021. The effective resistance of parallel connection that consists of 4 wires of equal length, equal area of cross section and the same material is 0.25. What will be the effective resistance if they are connected in series? Okay, super. Question number 118. So 4 resistors are there. So those are of equal length, equal area of same material also. Let's say that is R. R is equal to rho L by A. Okay. So R equivalent if all of them are connected in parallel, that is R by 4, which is equal to 0.25. It means R is equal to 1 ohm. Okay. These R is equal to 1 ohm resistors. All of them are connected in series. If all of them are connected in series, 1 ohm, 1 ohm, 1 ohm, then R equivalent is equal to 4 ohm. Which option? Option D is the correct answer for question number 118. Understood? Very good. Next, question number 119 is a direct question. From the current division principle, you can answer this directly. That is 119. Have a trick for this. So total current entering in the circuit. You can use this method whenever there is a current division or a charge division. So this is R1, entering current is I1. This current is dividing here I2 and I3, R2, R3. What's the question they are asking? Let's read it out. 3 resistors having resistances R1, R2 and R3 are connected as shown in the given circuit. The ratio of I3 by I1 of the currents in terms of resistances used in this circuit is okay. So they're asking I3 to I1 ratio. Let's find out current flowing through resistor I3. So I3 is resistor R3. I3 is equal to total current which is entering into opposite resistance we have to select, that is R2 divided by R2 plus R3. So we are talking about these two resistors only. Here only current is getting divided. That's why we have to select this. So I'll give you one more point. To find out current flowing through R2 resistance, then I2 is equal to total current in the circuit. Opposite resistance is R3 divided by R2 plus R3 is this is the current division principle that we have to use to answer quickly. Now the thing they are asking is I3 to I1 ratio, right? So which is equal to R2 by R2 plus R3. Which option? Option B is the correct answer again. Understood? Let's solve question number 120. In a potentiometer circuit, a cell of EMF 1.5 volt gives balance point at 36 centimeters length of the wire. If another cell of EMF 2.5 volts replaces the first cell, then at what length of the wire the balance point occurs? Okay. So this is based on second concept, that is comparison of EMF of two cells. So it's a direct formula, we can use this. That is E1 by E2 is equal to L1 by L2 over there. I have to find out L2. What's the value of E1? E1 is 1.5 volt. E2 is 2.5. Balancing point is 36 centimeters. Then I have to find out L2. So it can be replaced as 5 3s are 5 5s are, then 12s are. L2 is equal to 60 centimeter. Which option? Option A is the correct answer. Understood? Okay, next question number 121. A copper wire of length 10 meter and radius 10 power minus 2 by root 2 meter has electrical resistance of 10 ohm. The current density in the wire for an electric field strength of. We know the formula for electric field current density relation, that is J is equal to sigma E, right? So instead of sigma we can replace it with resistivity, that is rho. Now we know the formula for resistance in terms of resistivity, that is rho L by A. Then rho is equal to R A by L. Let me substitute it here. J is equal to sigma E by R A divided by L. Copper wire of length they have given, and radius 10 power minus 2 divided by pi meter is given. Radius is also given. Electrical resistance 10 ohm, that is also given. Current density of the wire, field strength also given. So J we have to find out. E value is 10, L is 10, R value is 10 power minus 2 divided by root pi. Is it root pi or pi? It's not root pi, it is only pi. Okay, in question they have given wrongly. So 10 power minus 2 divided by pi, and area they have given a radius, right? Oh, sorry. This is radius. It's correct only. Resistance is 10 ohms. Area is pi r square. R is 10 power minus 2 by root pi. Square in the sense 10 power minus 4 divided by pi. Pi will get cancelled out. This 10 will get cancelled. 10 power minus 4 goes to numerator. It will become 10 power 5. So final answer is 10 power 5 ampere per meter square. Two resistors of resistance 100 ohm and 200 ohm are connected in parallel in an electric circuit. The ratio of thermal energy developed in 100 ohm to the 200 ohm in a given time. Okay, as they are connected in parallel, voltage across them is the same. So 122 answer. Formula for thermal energy is heat energy, which is equal to power dissipated into time. Power formula is V square by R into T, as they are connected in parallel. So H1 divided by H2 is equal to R2 divided by R1, where R2 is 200, R1 is 100, which is equal to 2 by 1 ratio. Which option? Option 2 is the correct. Okay, so these are the numericals based on current electricity chapter. So as soon as possible, I am going to upload numericals based on moving charges and magnetism also. Thank you for watching. Have a great day.